exact words, you give one numerical number. So whenever that particular word appears, you substitute that word by that number. So this is called encoding technique. This is not used, but you should just understand what it is encoding. But this is not used currently. I mean, nobody uses encoding technique and all, but just understanding these. This was the origin. Initially they started with encoding, and then they moved on to much more sophisticated techniques of converting word into numerical representation. But you should just understand what it is, even though you don't use it. You should know how to you understand, and how to do it in spacey and LTK. You should understand. So, for example, in this small corpus, there are some 10 words. For each of these words, there is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So numbers are given 0 to 9. And so how it will be encoded? So you can call the pre-processing label encoder constructor, create an object, and then you can just call this fit transform on this animal list. Then label encoders, the encoding will be automatically created. You just have a list. You can call the label encoder constructor and then call fit transform on that list. The encoding will already automatically be created. Now you can just print out the encoding. So now for all the unique words, the encoding is created. So wherever dog comes, 1 will be substituted. Cat is 0. Wherever mouse comes, 3, the number 3 will be. So for every unique word, and numerical represent number will be given. You can do this using label encoder. You can also do the same using one-hot encoder, where you have a list and then you can call the one-hot encoder constructor, and then you can you have 9 animals. So wherever dog comes, it will be 1. The remaining places will be 0. This is one-hot encoding technique. This you might have learned in machine learning as well. So either you can go for encoding, or one-hot encoding is much better technique compared to encoding. And so wherever that particular animal comes, there 1 will be there, remaining places will be 0. So the next technique is POS taggers. See, the POS taggers is about, there will be certain use cases where you need to understand the parts of speech, what kind of text you have, natural language understanding based use cases and all. You might have to understand what kind of text you're dealing with. So if you want to understand the parts of speech of it, you can use either NLTK or Spacey. So each will have its own, each library has its own definition for parts of speech. So NLTK parts of speech tags will be different from Spacey parts. So you have to go to the documentation and check what are the tags in NLTK. You have to go and check the documentation for Spacey and check what are the tags, POS tags defined in Spacey. But generally, universally, if you see the parts of speech according to English grammar is, you will have adjective, adverb, prepositions, noun, determinants, verb. These are just common parts of speech and universally in English. But in NLTK and Spacey, there are certain parts of tags which they have implemented in that library that you see in the documentation. But how to use and generate the parts of speech? Very easy. In NLTK, you just call NLTK.POS, stands for parts of speech underscore tag. Pass the tokens for which you want the parts of speech. Tokens will be tagged and you can just print it out. Same, you can do it in Spacey also. You just have to use POS underscore. You will, for every word, if you put dot POS underscore, you will be able to find the parts of speech tag. So n-gram, so we have seen what is parts of speech, how to find the parts of speech in both NLTK and Spacey. So the n-grams, these are again some of the language modeling techniques where you can split the corpus into two words each. That is called bigram. If you split it to three words each, then that's called trigram. If you split it to single tokens, that is called unigram. So now you can do it in NLTK and in Spacey. So NLTK here it is shown. First they're splitting into, bigrams. So this is first 2 words, it is splitting into bigrams. You can also try splitting into 3 trigrams. Here they're splitting into 3 grams. So you can just use NLTK or Spacey you can use to create unigrams, bigrams and trigrams. Here she has shown only NLTK, but you can also experiment with Spacey as well. So the next technique is bag of words. So what is bag of words is? So bag of words is nothing but finding the frequency. For example, how many times dog in a heat needs more than shirt. Here dog is coming only once. And so how many times dog is coming? You'll take the raw text and then you'll find out the frequency of the text. That is what is bag of words. So for example, here we so here for this particular text, if you take O, fell, Drake, straight, body, bagging, weak, on the O stage. So here all the words are appearing only once. So the frequency for every word here will be only one. So you can use the bag of words in NLTK or Spacey, and you can just find the word token. You see, they have not used NLTK or Spacey here. They have just used simple logic. So for every word in the token, they are taking and they are seeing if it is already there in the word count. If it is not already there, then add plus one. If it is not already, if it's just first time the word is encountered, add give it the value one. If it is already there, just increment the counter by one. So this is a simple logic, but you have all libraries to find the bag of words as well. You can try that, or you can just write a simple manual logic to count the bag of words as well. So in this token, you have the bag of words as one for all the frequency of all the words is one. Then the word cloud. See, a lot of times for beautification reasons, people use word clouds. I don't see, personally, I don't see word clouds other than the beautification. I don't see any value out of word clouds. But you can people say instantly in visualization they'll be able to get some insights from word clouds and all. But whatever is it, I see it as a beautification thing. So if you want to find the word clouds, there is a package where you just pass the width and the height of the word clouds, and here they are generating passing a sample text, and then uh, the first in that list of tweets, they're taking the first tweet and they're sending it, then the word cloud is coming up. And just use matplotlib for printing your word cloud. So you can create word cloud using this word cloud constructor. So term frequency is nothing but, see, we found a bag of words where we are just finding the frequency. Term frequency is you find the frequency and you divide it by the total number of words. So fruit is coming 5 times. What is the total number of words in the document is 100. So term frequency will become 0.05. So this you don't have to do it manually. There is something called count vectorizer, which will find the term frequency for every word in your corpus. So here it is term frequency for the words. So what is inverse? But instead of term frequency, you will be frequently using inverse document frequency. So what is inverse document frequency is computed by using this formula, where here the TF stands for, first you will compute term frequency and then you will multiply it with another component which is log of. You will find the total number of documents, which is capital N, and you will find the number of documents which actually contains a given word. For what word you're finding the term frequency, you will find the number of times that particular word occurs. Total number of documents divided by number of, in addition to term frequency, you will compute this additional component, which is capital N stands for total number of documents and DF stands for number of words containing that X. This also you don't have to write any logic. You just call the TF-ID vectorizer. That will be do a fit transform on whatever text you want to find the TF-ID, and that will compute for you. You don't have to write any manual logic for it. See, this dependency parser and all is not actually required, but in Stanford, there is something called dependency parser, which will be able to tell you the relationship between the words. So if you want to find that, this is not actually significant in terms of the modeling, but it just you want to understand additional information about your text and something. These are tools which you can explore, but it's not actually required for this particular building a model. It's not required. And you can use Stanford dependency parser. You can access it from NLTK library, rich expression parser, and you can parse the tokens, and you should be able to print out a dependency parser. You can also use Spacey for dependency parser. Spacey is also called display.c.red. You'll be able to get the dependency parser from Spacey as well. You've got something called name entity recognition, which is very, very important. So here you convert, extract the noun and the proper phrases for your text. So here Albert Einstein is a person. So Germany is a location. Gymnasium is an organization. Zurich is a location. So you're splitting it to noun and proper noun phrases. You don't have to write the logic for it. NLTK has a library API function to do it. You just have to call any. The any stands for noun entity, named entity, underscore chunk, and pass the tokens for which you want the entities, and that will give you the named entities. You can do this in Spacey as well. You pass the text for which you want the named entities, and then that will give you the named entity recognition using Spacey as well. So word embeddings is something which we will be discussing in detail in the next class. But for now, you just understand word embeddings is a technique where you take a word and then you convert it into a numerical representation. We have done this earlier as well. But what's different between the earlier technique of encoding and word embedding is word embedding also captures the relationship between words. For example, you are not just blindly converting the words into token numerical representation, you are also capturing the relationship, contextual relationship of words. For example, king and queen have got contextual relationship, which is both belongs to the royalty, but king and queen are both belongs to the royal, the aristocratic things, but they are different because they're from different genders, men and women. So it captures the contextual relationship between words as well. So it's not just converting blindly words into numerical terms. You end up capturing the contextual relationship as well. There are three different major techniques for word embedding. Those techniques will be covered in detail next week, but for now you can just find out how to use gensum and convert to word embeddings. So you're just passing some text, and for each of the text you're converting a word embedding vector using the function. You're not writing anything from your from scratch. You're just using the existing functions to create the word embeddings. So principal component analysis and all is not required. And here, there she's using the sentiment analyzer, which is not just frequently used. So I'll just skip the sentiment analysis part. I'll teach you how to do sentiment analysis using XGBoost. But for the remaining techniques, I want you to replicate this to the next good reviews dataset. I'll tell you what all you should try in good review dataset. Try encoding, which you are taking a text and converting it to numerical values. And then one hot encoding as well. You take a string, maybe one sentence, tokenize a single sentence and pass that tokenized sentence. For that tokenized sentence, you find do the one hot encoding. Not for the entire corpus, just take one sentence and do one hot encoding, and take one sentence and do encoding, and find out the positional tag, POS tags for both using NLTK and Spacey. Find out the POS tags. Then you try n-grams, and then both here she has done NLTK. You can also look into the Spacey documentation, find out how to do language modeling using Spacey as well. You can experiment with that. Bag of words, here it is manually done. You can just try out to do from the packages in NLTK. Word cloud, you can try some other fractional experimentations as well, colors or something like that you can try to change. Find out term frequency is the number of times a word is occurring by total number of words. You can just take 5 or 10 sentences and you can do it. You don't have to do it for the entire corpus. And then you can find out inverse. Here also you are not going to write any logic from the scratch. You're just going to use the function which is already there. Dependency parser is not that important, but you can just write out in both Spacey and NLTK. Named entity recognition is a very important topic. Then she is done using NLTK and Spacey. Try out both. Word embeddings again using Jensen. So these are things which I want you to find out in good reviews dataset. Now the time is 4:12. I'll give you like 50 minutes, 40 minutes time. Try out as much as you can. And then if you're not able to do it, we'll discuss it in the class. Once you start practicing is when you will understand what is when you'll realize what are the things, where are you getting stuck at. So get started with it. This is a sample code is already available. You're just going to try it on a different data set. So once you do this, once you complete this, finally I'll be teaching you how to build. We have seen pre-processing. Now I've discussed some of the feature engineering techniques. How to use these features and create an end-to-end model is what we're going to see next. I want you to take 40 minutes time and replicate all these techniques on the good review data set. And we'll catch up at 4:50. One of you will go through the solution as well.
Can I ask a question, madam, now?
Yeah, please.
Okay. So when we say feature engineering, are we generally we refer to the features like, so what comes as a variables, right, in the data set. But here in this context, it is the words that we parsed, and that is in the context that becomes the features. Is that right?
Yeah, because machine learning, the traditional machine learning, what you've seen in the previous thing was tabular data. So tabular data, you get handcrafted features, right? But in NLP text and then images, you don't get such handcrafted features. You just get a lot of unstructured text. You have to extract features out of it, right? But if you take any machine learning problem, iris data set, you get features already, handcrafted features, length of the flower, width of the flower, and all that you get, right? But here you don't get handcrafted features. You have to generate features using TF-IDF and all these techniques. You will not use all the feature techniques which we saw. TF-IDF is frequently used. Other than that, I don't see many techniques being used. TF-IDF is what word vector, word to word embeddings will be frequently used, and TF-IDF will be used. Word embeddings is the most important concept, which now only I'm introducing you to word embeddings. Next week is when we'll get into detail with some of the word embeddings which are available like glove, what to make, and all that. But this week we'll just understand intuition or whatever it is. So here text data is a lot of unstructured data. There's no handcrafted features here. So you're using some of the techniques, whatever we discuss here, you use to generate features. But there are a lot of things what we discussed today which you won't use at all. But still, you should understand and know how to use it. That's all.
Okay, got it. Thank you.
Yeah. So sample notebook is given. You are just going to replicate to a different data set. This is simple, right? You did the pre-processing, the same thing you are going to do it now. The reason why you are doing it is only when you do it, you will actually understand a lot of things. Otherwise, like simply listening, you will feel like you will understood, but it's only when you practice, you will understand a lot more things. So, any other questions? See, the feature engineering, most important concepts here is named entity recognition, TF-IDF, and word embeddings. Word embeddings, there are three techniques which will be discussed in detail next week. But these are the most frequently used things which you will be using it commonly in the second, third, and fourth week. But other techniques also you should understand. Even if you don't frequently use it, you should understand what it is and you should be familiar with those things. There is nothing you're going to do it from the scratch. You're not right. See, throughout the notebook, did you see anything which is written, logic which is written from the scratch? No. For all of it, the packages and functions are available. You just have to use a corresponding function, whether you use NLTK or Spacey, or there are other libraries as well outside. Whatever library you want, you can use. You just have to know, or you should go to the official documentation. What is the method which does the job for you? What are the parameters it takes? What does each parameter means, and how to get the job done using that method. Whatever library you want, you can use it. To you have an end goal, you can achieve that using any library. You want to generate numerical features from text, you can end goal is you want numerical features, that's all. Whether you use NLTK or Spacey or any other library doesn't matter. You just have to acquire numerical features. That's all that matters. So you can use any library of your choice, but what you this is underlying concept, underlying thing here is just basics of any programming. You just need to understand how one particular API works, how a particular function works in a library, what are the parameters it takes, how to use a function. You should know how to go to a documentation of a new library and then find out what functions it, what are the parameters it accepts, what is the syntax for that, how to use it. These are basic techniques, fundamentals of programming. So if you, irrespective of Java or any language you understand, you should be able to do it in Python as well. So here the task is very simple. What I want you to do is I've taught some feature engineering techniques. Just try it out on a different data set. So some of it may not be important, but still try it out. That's when you actually understand a lot more. So you can try something new, like you take word cloud. How can you bring in different colors? How can you change the dimensions? So small innovations you can do. You can go to the documentation, see what are the different parameter values it can take. Small experimentations you can do. Yeah. Anything else?
You want us to pick the example on our own, or you have
You can
recommended
use
something
a
which
good review data set. For the same data set, you can create. You use good reviews for the pre-processing, right? Continue with the same data set.
okay.
Yeah. So please complete it by 4:50. After that, I have to teach the modeling as well. So complete it on time. We have time only for one candidate. So I'll pick one candidate at random, and you have to explain the solution. Then we'll move on to modeling, and then your assignment data set will be given, which you have to submit by Monday EOD. Please start practicing now, and then complete the test by 4:50.
Ma'am, one question. I'm still trying to understand, trying to figure out the purpose of feature engineering in NLP. Okay, so I understand the concepts, some of the concepts, not everything. TF-IDF I knew, pod embedding I need to explore. So those are the techniques for used for feature engineering. So what is the objective? Like what we'll get basically out of using those techniques? What you are trying to derive using feature engineering? What is our objective? Ma'am is
Amanda,
there?
so she left.
Okay.
When she joins back, you
Okay.
can repeat the question.
Mhm.